The implications of these nomadic worlds extend far beyond planetary science. Some rogue planets, particularly those with thick atmospheres or subsurface oceans, might harbor conditions suitable for life. In the absence of a star, internal heat from radioactive decay and tidal forces could sustain liquid water beneath an icy crust, much like Jupiter's moon Europa or Saturn's Enceladus. Could life exist in the deep oceans of a planet adrift in the interstellar void? Even more intriguingly, rogue planets may serve as stepping stones for future interstellar travel. Their gravitational wells could provide slingshot assists for spacecraft, or in an even more speculative scenario, they could be natural way stations, offering resources to advanced civilizations exploring the galaxy. If humanity ever reaches the stars, could we one day set foot on a world that has never known a sunrise? If rogue planets are as abundant as some theories suggest, they could outnumber stars in the Milky Way. This realization forces us to rethink the nature of planetary systems. Are solar systems like our own the exception rather than the rule? Could rogue planets be the dominant form of planetary existence, silently drifting through the darkness in numbers beyond our comprehension? Detecting these elusive wanderers remains a significant challenge. Without a parent star to illuminate them, they remain shrouded in darkness, evading traditional observational methods. However, advancements in infrared astronomy and gravitational microlensing techniques have provided tantalizing glimpses of these mysterious objects. Missions like the upcoming Nancy Grace Roman Space Telescope aim to uncover more of these hidden worlds, revealing their true population characteristics. One of the most mind-bending aspects of rogue planets is the possibility that some could be massive enough to retain thick atmospheres capable of trapping heat. Even without a sun, geothermal energy from radioactive decay or residual formation heat could sustain subsurface oceans, turning these planets into icy yet potentially habitable refuges. If microbial life can thrive in Earth's deep-sea hydrothermal vents, could it also exist in the buried oceans of a rogue planet? Some scientists even speculate that extremophiles, organisms adapted to harsh conditions, might find ways to persist in the perpetual twilight of these wandering worlds. But what if rogue planets aren't entirely alone? Theoretical models suggest that some might host their own moon systems, locked in silent companionship as they drift through interstellar space. These moons, if large enough, could even maintain their own atmospheres, influenced by the gravitational dynamics of their parent planet. Imagine a rogue planet with an entire miniature solar system in tow, a self-contained world system cast out from its star, yet still bound together by gravity. Even more astonishing is the idea that rogue planets could serve as interstellar arcs. If an advanced civilization existed on a planet that was ejected from its solar system, could they find a way to survive? Would they build artificial energy sources to replace their lost sun, or harness the heat from their planet's core? Science fiction has long speculated about such rogue worlds, where intelligent beings adapt to the cold and darkness, creating civilizations that thrive in the abyss. If rogue planets can sustain life for millions or even billions of years, could some be home to alien species, isolated from the rest of the galaxy but evolving in their own unique ways? Rogue planets also challenge our understanding of planetary migration. Traditionally, we think of planets forming within a solar system and remaining bound to their stars unless disrupted by external forces. But the chaotic reality of planetary dynamics suggests that ejections might be common, with newly forming planets flung into deep space by the gravitational tugs of larger neighbors. This means that rogue planets might not just be young objects, they could be ancient relics, castaways from long-dead star systems that have been traveling the interstellar void for eons. Some could even be survivors from other galaxies, kicked out during violent galactic interactions and now drifting through the Milky Way, carrying the chemical fingerprints of their distant origins. And then there's the possibility of planetary capture. If rogue planets roam freely, could some eventually be recaptured by other star systems? If a wandering planet drifts close enough to a young, forming star system, its gravity could ensnare it, making it a late addition to the planetary family. This raises an exciting question: could some of the planets we observe today, even within our own solar system, have once been rogues, only to find a new home orbiting a star? The study of rogue planets is still in its infancy, but as observational technology improves, we may soon uncover more of these celestial nomads. Perhaps one day, we will send probes to explore a rogue world firsthand, landing on its frozen surface, drilling into its depths, and searching for signs of life that has endured against all odds. Or maybe, in some far-off future, humanity itself will use rogue planets as stepping stones, leaping from one to another as we explore the vastness of the cosmos. In the end, rogue planets embody the essence of cosmic mystery, silent travelers in an endless night, each one holding secrets that could redefine our understanding of planets, life, and the universe itself. If rogue planets are as abundant as some theories suggest, they may be more than just cosmic wanderers. They could be the hidden keystones of planetary evolution, remnants of past celestial upheavals, or even cradles of unknown life forms. Their mere existence forces us to reconsider fundamental questions about planetary systems. Are they truly rare, stable constructs, or is chaos the natural order of the universe? Could rogue planets be the discarded building blocks of countless shattered solar systems, each carrying the scars of an ancient gravitational battle? One of the most fascinating aspects of rogue planets is their potential diversity. Unlike planets bound to stars, which are constrained by the material available in their protoplanetary disks, rogue planets could have formed under vastly different conditions. Some may be rocky like Earth, others gas giants resembling Jupiter, while a few might be strange hybrid worlds, partially frozen, partially molten, shaped by forces we have yet to fully understand. The variety of rogue planets may surpass what we see in traditional planetary systems, offering new insights into the formation and evolution of planets across the universe. Consider the possibility of rogue super-Earths, massive terrestrial planets with thick atmospheres capable of trapping heat for billions of years. These planets, despite being cut off from the warmth of a star, could sustain internal heat sources, keeping parts of their surfaces or interiors warm enough for liquid water to exist. If life developed in such an environment, it would evolve in complete isolation from stellar influences, adapting to an eternal twilight world where energy is scarce, but survival is still possible. What kind of ecosystems might arise in such conditions? Would alien organisms rely on chemical energy, like extremophiles on Earth? Could we one day discover a biosphere hidden beneath a thick ice shell, thriving in the unlikeliest of places? Beyond biology, rogue planets also hold potential as stepping stones for space exploration. In the distant future, when humanity begins to expand beyond our solar system, rogue planets could serve as natural refueling stations, oases in the desert of space. Their frozen surfaces might contain vast reservoirs of water ice, which could be converted into fuel for spacecraft. Some could possess valuable minerals or even stable atmospheres, making them temporary havens for deep space travelers. If rogue planets exist in great numbers, interstellar journeys might not require massive self-sustaining spacecraft but instead a series of calculated jumps from one wandering world to the next. Even more provocatively, rogue planets might not all be naturally occurring. What if some have been engineered? Advanced civilizations, if they exist, might use rogue planets as mobile bases, harnessing their gravity as natural shields against cosmic radiation while traveling through interstellar space. This leads to the staggering possibility that some rogue planets could be artificial, planet-sized constructs, hollowed out and transformed into massive generation ships, carrying entire civilizations across the galaxy. If such objects exist, they would be nearly impossible to detect unless they revealed themselves intentionally. Could humanity one day stumble upon an ancient, drifting world ship, its inhabitants long gone or perhaps still alive, traversing the stars on an endless voyage? The vastness of the cosmos ensures that rogue planets remain some of the least understood yet most intriguing celestial bodies. Their role in the grand cosmic narrative is still being written, but one thing is certain: they challenge our perceptions of what a planet is, how it forms, and what it can become. As telescopes improve and space missions venture deeper into the unknown, rogue planets may go from being cosmic mysteries to key players in our quest to understand the universe. They are not merely lost worlds, they are the silent sentinels of interstellar space, drifting through the void, waiting to be discovered. The more we learn about rogue planets, the more they seem like cosmic paradoxes, both isolated and yet potentially teeming with possibility. They exist in the coldest, loneliest stretches of interstellar space, yet they might hold environments where life could thrive. They drift untethered from any solar system, yet they could serve as waypoints or even homes for future explorers. Their very existence challenges the neat categorizations we impose on celestial objects, blurring the lines between planets, moons, and even failed stars. One of the greatest mysteries surrounding rogue planets is their composition. Without a parent star's light to analyze, astronomers must rely on indirect methods to determine what these planets are made of. Gravitational microlensing, where a rogue planet passes in front of a distant star, briefly magnifying its light, provides clues about its size and mass. But beyond that, rogue planets remain largely invisible to our current instruments. This has led to wild but intriguing speculation. Could some rogue planets be made of exotic materials unlike anything found in our solar system? Could some be carbon planets, with vast landscapes of graphite and diamond beneath their surfaces? Or even iron-rich worlds, dense and heavy, forged in environments we have yet to understand? Then there's the question of rogue planets that might be remnants of destroyed solar systems. If a star goes supernova, its planets may be violently ejected into space, flung away at tremendous speeds. These planetary refugees could carry within them the chemical signatures of their former stellar homes, serving as relics of long-dead stars. Some rogue planets may have once orbited binary stars or existed in chaotic, multi-planet systems where gravitational interactions tore them free. In some cases, they may still carry frozen atmospheres or remnants of past oceans, locked away beneath thick layers of ice. Perhaps the most speculative but thrilling possibility is that rogue planets might act as messengers of life. If they are ejected from their home systems with intact biospheres, oceans, underground ecosystems, or even microbial life within frozen lakes, they could transport life across interstellar distances in a process similar to panspermia, but on a much larger scale. A rogue planet drifting for millions of years might eventually pass close enough to a young star system to be captured. If it carries organic material or even living microbes, could it help seed life on new planets? Could some of the building blocks of life on Earth have originated from such a planetary traveler billions of years ago? In a more distant future, rogue planets could play a role in humanity's survival. If, one day, Earth faces an existential catastrophe, whether from a dying sun, an asteroid impact, or a man-made disaster, escaping to another star system might be an insurmountable challenge. But a rogue planet passing close enough to our solar system could provide an unexpected escape route. If such a planet had resources we could harness, or if it was on a trajectory that would eventually bring it near a habitable zone in another star system, it could offer an alternative means of interstellar travel. Rather than building massive space stations or generation ships, could we one day hitch a ride on a passing rogue planet, adapting to its conditions as it carries us through the void? As technology advances, we may finally be able to study these mysterious worlds up close. Future space telescopes with powerful infrared sensors could reveal their atmospheres, their surface compositions, and even the presence of potential biosignatures. If we discover evidence of life on a rogue planet, it would shatter our understanding of how and where life can exist. It would prove that life does not require a sun, that it can endure the endless night, and that the universe is far more hospitable than we ever imagined. Rogue planets are more than just cosmic wanderers, they are pieces of a much larger puzzle. They may hold the secrets to planetary formation, the nature of interstellar travel, and even the origins of life itself. Silent and unseen, they drift through the abyss, waiting for the moment when we finally turn our gaze toward them and uncover the truths they have carried for eons. If rogue planets are truly as numerous as some estimates suggest, then the galaxy is not an empty void but a vast ocean filled with these hidden wanderers, unseen and uncharted. They may exist in the billions, drifting between the stars like cosmic ghosts, each one a mystery waiting to be unraveled. These planets challenge our understanding of what it means to be part of a planetary system, because, in truth, they have none. They are worlds without suns, existing in eternal darkness, yet possibly brimming with geological activity, subsurface oceans, or even the raw ingredients for life. The idea that life could exist on a rogue planet may seem counterintuitive at first. After all, we associate life with the presence of a stable star providing warmth and energy. However, the discovery of deep-sea hydrothermal vents on Earth, where entire ecosystems thrive without sunlight, relying instead on the heat and minerals rising from the ocean floor, has forced scientists to reconsider what is truly necessary for life. If life can persist in such extreme conditions on Earth, could it also emerge in the depths of a rogue planet's hidden ocean? Imagine a rogue planet with a thick, insulating atmosphere, rich in greenhouse gases like methane and carbon dioxide, trapping heat from its own internal processes. Beneath a thick shell of ice, a vast ocean could exist, kept liquid by the warmth generated from the planet's core. In this isolated world, life would not depend on photosynthesis but instead on chemosynthesis, much like the organisms found around Earth's deep-sea vents. Strange, alien creatures could lurk in these hidden oceans, perhaps simple microbial life, or even complex organisms adapted to an existence where the only source of energy comes from the chemistry of the water itself. If such environments exist, how would we ever detect them? Finding rogue planets is already difficult, but confirming the presence of subsurface oceans or biological activity is an even greater challenge. Some astronomers propose using future space telescopes to search for telltale signs of atmospheric outgassing, gases like methane or oxygen escaping from beneath an ice shell, hinting at biological or geothermal activity. Others suggest that if a rogue planet were to pass through a region of space dense with interstellar dust, its atmosphere might briefly become visible, revealing its composition. But rogue planets may hold secrets beyond biology. They could be archives of cosmic history, preserving clues about the processes that shape planetary systems. Unlike planets bound to stars, rogue planets are not constantly bombarded by solar radiation or stripped of their atmospheres by stellar winds. This means that their surfaces, and any atmospheres they might retain, could remain largely unchanged for billions of years, providing pristine records of the conditions under which they formed. A rogue planet could be an ancient time capsule, holding answers to questions about the early universe, the chemistry of interstellar space, and the forces that sculpt planets across the cosmos. Even more intriguingly, some rogue planets may not be entirely alone. There is a possibility that some could retain moons, small celestial bodies that remain gravitationally bound to them despite their journey through the void. These moons could be as diverse as the ones found in our solar system, ranging from barren, cratered surfaces to icy worlds with internal oceans. In such cases, a rogue planet might not be a solitary traveler, but a miniature planetary system unto itself, carrying its own unique history and potential for discovery. The implications for future space exploration are staggering. If humanity ever reaches the point where interstellar travel becomes feasible, rogue planets could serve as natural stepping stones across the cosmos. They could be refueling stations, with vast reservoirs of water ice that could be converted into hydrogen fuel. They could be shelters, offering gravity, resources, and protection from cosmic radiation. If an advanced civilization were to expand across the galaxy, they might use rogue planets as mobile bases, constructing self-sustaining colonies that drift through space, independent of any star. But the most astonishing possibility remains the question of whether we might one day encounter a rogue planet that is not just a lifeless rock or an icy ocean world, but one that is inhabited. If life can exist on such worlds, then the galaxy could be filled with drifting ecosystems, self-contained biospheres that have never known sunlight. If intelligent life were to arise in such a place, their perception of the universe would be radically different from our own. Without a sky illuminated by a star, would they ever conceive of the idea of a sun? Would they view the cosmos as an endless abyss, unaware that other planetary systems even exist? If we were to make contact with such beings, would they see us as creatures of fire and light, emerging from the blinding glare of the stars they have never known? The more we contemplate rogue planets, the more they seem to be an integral part of the galaxy's structure, not just anomalies or lost worlds but key players in the grand cosmic drama. They are remnants of shattered solar systems, laboratories of planetary science, and potential cradles of alien life. Each one is a world adrift, carrying the secrets of its origin, its journey, and perhaps even the future of interstellar exploration. If rogue planets are the forgotten wanderers of the cosmos, then what stories do they tell? Are they the silent remnants of ancient catastrophes, torn from their home systems in violent celestial battles? Are they the exiles of the universe, drifting endlessly through the interstellar abyss? Or could they be something more, hidden worlds carrying secrets about the past, present, and future of planetary evolution, and perhaps even life itself. One of the greatest mysteries surrounding rogue planets is their possible variety. Not all rogue planets are necessarily frozen wastelands. Some may still carry the warmth of their formation, locked within their dense interiors. Others could be gas giants, retaining thick atmospheres that trap residual heat, creating warm, cloud-covered worlds adrift in perpetual twilight. Some may have active volcanoes, spewing heat into their atmospheres, sustaining environments vastly different from the icy, desolate worlds we often imagine. Could there be rogue planets that are not just habitable, but even comfortable? Planets with thick atmospheres, liquid water, and stable conditions, yet without a sun. The concept of warm rogue planets challenges our assumptions about where life can exist. A massive rogue planet with a dense hydrogen-rich atmosphere might retain enough heat to keep its surface warm for billions of years. On such a world, oceans could remain liquid, and clouds might form in a never-ending cycle of precipitation and evaporation, similar to what we see on Earth. In the absence of a sun, life would need to adapt to alternative energy sources. Could organisms evolve to harness chemical reactions instead of sunlight? Would bioluminescence play a crucial role in such ecosystems, with life forms generating their own light in the eternal darkness? And what if rogue planets aren't merely natural phenomena? The idea that some of them might be artificial, or at least modified by an advanced civilization, is one of the most tantalizing possibilities in astrobiology. A technologically advanced species facing planetary catastrophe might choose to turn their home world into a drifting ark, sustaining their civilization as they traverse the galaxy. Enormous megastructures could be built to capture and store energy, artificial light sources could replace the lost warmth of a sun, and underground or subsurface cities might allow for long-term survival. If such civilizations exist, would they even recognize themselves as part of a larger cosmic community, or would they see their world as the only one, forever drifting through a void that, to them, is natural? These ideas lead to even deeper questions about rogue planets as vessels for interstellar migration. If an advanced species developed the capability to manipulate planetary orbits, an idea not as far-fetched as it sounds given our own nascent experiments with asteroid redirection, could they engineer the movement of an entire planet? Could rogue planets serve as natural generation ships, slowly crossing the galaxy over millions of years, carrying life to distant star systems? And if such civilizations exist, could we one day detect them, not through radio signals, but by spotting rogue planets with unexpected patterns of movement, suggesting intelligent guidance? Even if rogue planets are not artificial, their role in galactic evolution cannot be ignored. These wandering worlds may act as seeds of planetary formation, bringing essential elements to young solar systems. If a rogue planet passes through a protoplanetary disk, a swirling mass of gas and dust surrounding a young star, it could introduce heavy elements, ice, or even organic molecules that help shape the planets forming within that system. Could our own solar system have been influenced by such a passing world in its infancy, depositing materials that contributed to the formation of Earth? And what about rogue planets that may have once been Earth-like? If a planet was ejected from its solar system after billions of years of stable conditions, could it carry frozen remnants of its former life? Could some rogue planets be ancient, drifting time capsules, preserving biospheres that once thrived in the warmth of a distant sun? If we ever found such a world, could we extract and revive ancient microbes, uncovering life forms that lived on a completely different timeline from our own? The sheer number of rogue planets also raises another question: how many of them have passed through our solar system without us noticing? Current estimates suggest that rogue planets may outnumber stars, meaning that over the course of Earth's history, some may have drifted close to our Sun, only to pass through unnoticed before continuing their journey. Could rogue planets occasionally enter the outer reaches of our solar system, disturbing the orbits of distant objects, and then vanish once more into the void? Some astronomers even speculate that our hypothetical Planet 9, an unseen massive world thought to lurk beyond Neptune, could itself be a captured rogue planet, drawn into our Sun's gravitational grip eons ago. The search for rogue planets is only just beginning. Future telescopes, particularly those capable of detecting faint infrared signatures, may reveal thousands, perhaps millions, of these lost worlds. With each new discovery, we inch closer to understanding their origins, their potential for life, and their role in shaping the cosmos. But rogue planets remain one of the universe's greatest enigmas, existing on the fringes of our knowledge, challenging everything we assume about planets, life, and the nature of existence itself. They are the silent travelers of the universe, the nomads of the stars, the lost children of solar systems that once were. And as we turn our gaze toward the depths of interstellar space, we may one day realize that these drifting worlds have been watching us all along. If rogue planets are as abundant as some models predict, then the very fabric of our understanding of planetary evolution is incomplete. We think of solar systems as the cosmic norm, yet the vast majority of planets may not belong to any system at all. Instead, they wander alone, unseen and untethered, defying the conventional wisdom that planets must revolve around stars. This realization forces us to ask, if rogue planets are so common, why do we know so little about them? The answer lies in their invisibility. Without a parent star, these planets do not reflect sunlight like the worlds in our own solar system. They remain hidden, detectable only through fleeting gravitational microlensing events or the faint glow of residual heat. This means that our current catalog of rogue planets represents only the tiniest fraction of what is truly out there. The Milky Way may be filled with these lost worlds, drifting silently in the darkness, their numbers dwarfing all the stars we see in the sky. One of the most compelling possibilities is that rogue planets could serve as natural interstellar arcs, transporting life across the galaxy. If a planet is ejected from its solar system with intact oceans, frozen atmospheres, or underground reservoirs, could microbial life survive the journey? Here on Earth, we've discovered life thriving in extreme conditions, within the frozen Antarctic ice, deep beneath the ocean floor, and even inside nuclear reactors. If life can endure such environments, could it also withstand the frigid, radiation-filled expanse of interstellar space? Some scientists believe that certain microorganisms, such as tardigrades and bacterial spores, could survive for millions of years in the right conditions. If a rogue planet were once habitable, it might preserve its biosphere in a frozen state, waiting for the right moment to thaw. Imagine a world, lost for eons, suddenly captured by a new star system, its icy oceans melting, its atmosphere rekindled, and the seeds of life reawakening after a journey through the void. If this scenario is possible, then rogue planets could be agents of panspermia, spreading biological material from one star system to another. This would mean that life, instead of being confined to individual planets, might exist as a galactic phenomenon, carried across the cosmos by the silent drift of these planetary travelers. Among the many unknowns surrounding rogue planets, one of the most intriguing questions is their size distribution. Some may be small, rocky worlds like Mars, while others could be gas giants like Jupiter. But an especially interesting class of rogue planets would be super-Earths and mini-Neptunes, planets larger than Earth but smaller than Uranus. Super-Earths, if rogue, could retain thick atmospheres that trap heat, allowing for liquid water even without a star. A high-pressure greenhouse effect might keep the surface warm for billions of years. Some mini-Neptunes, on the other hand, might have deep subsurface oceans hidden beneath thick hydrogen atmospheres. These warm ice worlds could maintain liquid water layers under intense pressure, much like what scientists suspect exists on Neptune's moon Triton or Saturn's Enceladus. If rogue planets like these exist in great numbers, then habitable environments may be scattered throughout the galaxy, not just in the habitable zones around stars, but drifting freely in the vastness of space. The idea of rogue planets has also sparked speculation about the outer reaches of our own solar system. Some astronomers believe that an unseen giant planet, sometimes called Planet 9, may be lurking in the distant Kuiper Belt or beyond. Could it be a captured rogue planet that was drawn into our Sun's gravitational field long ago? If so, it would be a rare example of a rogue planet finding a new home. But how many others have simply passed through, unnoticed? Over the billions of years of the solar system's history, rogue planets may have visited the outskirts of our Sun's domain, disrupting comets, stirring up asteroids, and then vanishing back into interstellar space. If one such planet were on a trajectory that brought it close to Earth, how would we detect it? Current telescope surveys focus on exoplanets around stars, but new missions dedicated to hunting rogue planets may one day reveal whether such worlds have come near us before, or whether one is approaching even now. As our technology improves, the search for rogue planets is accelerating. The upcoming Nancy Grace Roman Space Telescope and Euclid mission are expected to detect hundreds, if not thousands, of rogue planets through gravitational microlensing. With each new discovery, we will gain a clearer picture of how common these planets truly are and what their properties reveal about planetary formation and migration. But direct exploration remains a daunting challenge. Unlike planets orbiting stars, rogue planets are not confined to predictable paths. They do not emit light, making them incredibly difficult to locate with traditional telescopes. Future space probes might need to use infrared sensors to scan deep space for the faint heat signatures of these elusive worlds. If a rogue planet were discovered relatively close to Earth, perhaps only a few light-years away, it could become the first interstellar destination for a future mission. Could we send a robotic lander to explore its surface? Could we drill into its icy crust, searching for signs of liquid water and possible microbial life? And if, one day, we find a rogue planet teeming with life, what would that mean for our understanding of the universe? It would prove that life is not just bound to the warmth of stars. It would show that the galaxy is alive in ways we never imagined, that in the cold, dark spaces between the stars, entire ecosystems may exist, hidden from view, waiting to be discovered. Rogue planets remain one of the greatest cosmic mysteries. They defy the structure of traditional planetary systems, rewriting the rules of how we think about worlds, habitability, and even life itself. They challenge our assumptions about what is normal in the universe, forcing us to consider the possibility that the Milky Way is teeming with hidden, unseen planets, drifting in the darkness, each one a silent witness to the chaotic history of the cosmos. Perhaps one day, we will encounter one of these lost worlds up close. Perhaps we will set foot on a planet that has never known the light of a sun. Perhaps we will find life, not as we know it, but as it has adapted to the endless night. And when that moment comes, we will finally understand that the universe is far stranger, more diverse, and more mysterious than we ever dared to dream. If rogue planets are as plentiful as some estimates suggest, they may be the unseen architects of cosmic change. These drifting worlds, untethered from the gravitational embrace of stars, could play a role in shaping the evolution of planetary systems, altering the trajectories of comets, and even seeding life across the galaxy. They are the silent travelers of the universe, passing through interstellar space on timescales that dwarf human history, their fates unknown, their journeys dictated by the chaotic interplay of gravity and chance. While rogue planets spend most of their existence in the deep void, they are not necessarily doomed to eternal isolation. Some may venture close to existing star systems, their paths bending under the influence of stellar gravity. In rare cases, they might be captured by a star's pull, joining its planetary family as an outsider, an interloper that once roamed free but now follows an orbit dictated by its new host. If rogue planets occasionally enter solar systems, they could have dramatic effects on existing planetary architectures. A massive rogue planet passing through a young star system could disrupt forming planets, flinging them into new orbits or ejecting them entirely. In a system with a fragile habitable zone, a rogue planet's gravitational influence could spell doom for life-bearing worlds, pushing them into freezing darkness or scorching proximity to their star. But rogue planets could also be creators, not just destroyers. If one were to pass through a protoplanetary disk, a swirling cloud of gas and dust where planets are born, it might seed that region with materials from another part of the galaxy. If it carried water ice, carbon compounds, or complex molecules formed in deep space, it could contribute to the chemistry of young planets, perhaps even accelerating the emergence of life. Most rogue planets are thought to be solitary wanderers, but what if some travel in groups? There is a possibility that some rogue planets were ejected not alone, but along with their moons. These systems, miniature solar systems floating freely through space, could remain gravitationally bound, even in interstellar isolation. Imagine a massive rogue gas giant with multiple moons, some of them harboring underground oceans like Europa or Enceladus. The gravitational interactions between the planet and its moons could generate tidal heating, keeping liquid water warm even without a star. In such an environment, life might persist for billions of years, evolving in total darkness, guided by forces we can only begin to imagine. Could these rogue planet systems be more than just anomalies? Could they be common, forming entire communities of drifting worlds that share a common history? If so, they could represent a new category of celestial bodies, planetary clusters adrift in interstellar space, untethered to any sun, yet bound together by their own internal gravities. If a civilization were to develop far enough, could it one day take control of an entire planet's trajectory? Could intelligent life engineer a rogue planet, deliberately detaching it from its parent star to use as a mobile base, a generational spacecraft, or even a cosmic ark? At first glance, the idea seems like pure science fiction. But when considering the vast timescales of the universe, it becomes a possibility worth exploring. Advanced species could use massive energy sources, perhaps harnessing the heat of the planet's core or constructing artificial suns, to create sustainable, long-term environments on these wandering worlds. If such civilizations exist, they might not need to settle around stars at all. They could be nomads, moving from one system to another, living entirely on rogue planets that drift through space like colossal, self-sufficient spacecraft. What if we've already encountered evidence of such civilizations, but failed to recognize it? Some researchers have speculated that certain anomalies in cosmic signals or planetary motion might be the result of artificial constructs, perhaps rogue planets that were deliberately modified by intelligent beings long ago. As Earth's technological civilizations advance, we will eventually face the challenge of expanding beyond our planet. Space stations, Mars colonies, and interstellar travel are often proposed as solutions, but what if rogue planets themselves offer a viable alternative? A well-positioned rogue planet, if rich in resources and close enough to our solar system, could serve as an ideal way station for deep space exploration. Its gravity would provide a natural anchor, its ice deposits could be used for fuel and water, and its isolation from a star might make it a safer haven from cosmic radiation. If we one day discover a rogue planet that has all the elements necessary for sustaining life, could humanity terraform it, building cities and ecosystems within its underground oceans or thick atmosphere? Even more dramatically, what if Earth itself were someday transformed into a rogue planet? If our sun were to expand into a red giant, engulfing the inner solar system, would it be possible, no matter how far-fetched, to move Earth out of harm's way? While such an endeavor is far beyond our current technology, it is not physically impossible. Using gravitational assists, planetary propulsion, or even controlled asteroid impacts, an advanced civilization might one day attempt to migrate an entire planet into interstellar space, transforming it into a rogue world of its own. For now, rogue planets remain one of the greatest enigmas of the cosmos. They are the silent nomads, the lost worlds, the celestial wanderers that defy the rules of planetary science. They exist in numbers beyond counting, yet we have barely begun to understand them. Are they relics of violent cosmic events, or are they natural stepping stones for life spread across the galaxy? Are they lonely and barren, or are they teeming with hidden ecosystems, thriving in the darkness? And the biggest question of all, what will we find when we finally visit one? Will it be a frozen wasteland, untouched since the dawn of time? A warm ocean world, its life forms hidden beneath layers of ice? A massive gas giant, swirling with unknown chemistry? Or something far stranger, something we never expected, something that rewrites our understanding of what it means to be a planet at all? Perhaps, in some distant future, a human explorer will step onto the surface of a rogue planet, looking up into a sky without stars, standing on a world that has known only darkness. And in that moment, they will realize that these planets, though silent, have been waiting for us all along. Waiting to show us that even in the emptiest reaches of the universe, the cosmos is never truly empty. Rogue planets drift through the infinite dark, unseen and untethered, their existence barely whispering against the vast silence of space. Some are ancient relics, born in the fires of forgotten star systems, cast out by gravitational turmoil, doomed to wander forever. Others may have formed alone, deep in the interstellar void, where no star has ever shone upon them. Each one carries a history written in silence, a story etched in frozen landscapes and deep, unseen oceans. Some of these worlds may still glow faintly with the heat of their birth, their cores burning dimly beneath thick layers of rock and ice. Others have gone cold, locked in a timeless drift, their surfaces sculpted only by the rare collisions of cosmic debris. They move with no purpose, no destination, yet they follow invisible gravitational threads, their courses dictated by forces beyond human comprehension. And yet, despite their isolation, they are not truly alone. The galaxy is filled with unseen forces, and rogue planets may pass close to stars, brushing against the edges of solar systems, altering the delicate balance of planetary orbits before vanishing once more into the abyss. Some may be caught in the gravitational grip of a passing star, pulled into new orbits, given a second chance at warmth and light. Others may slip through unnoticed, their presence betrayed only by the faintest flicker in a distant star's glow, a momentary gravitational lensing event that tells of something massive, something unseen, something wandering. If a rogue planet harbored life before its ejection, what would become of it? A planet suddenly cast into the dark would see its surface freeze, its atmosphere condense into ice, its oceans locking away whatever secrets they held. But beneath the frozen shell, warmth from the planet's core might persist for millions, even billions of years. Life, if it had adapted to the deep, lightless oceans, might not even notice the change. Entire ecosystems could persist in these hidden worlds, sealed away beneath thick layers of ice, sustained by volcanic heat and chemical reactions. Could there be rogue planets that have carried life across the galaxy, moving unseen between the stars, preserving ancient organisms in the depths of their oceans? Some rogue planets may still have moons, companions that remain gravitationally bound to them even in interstellar exile. These moons could experience tidal heating, much like Europa and Enceladus in our own solar system, their interiors warmed by the relentless pull of their parent planet. Even in the coldest reaches of space, this heat could be enough to sustain subsurface oceans, creating environments where life could emerge, thrive, and evolve in total isolation from the light of any star. In such a place, evolution would take an entirely different path, shaped not by day and night, not by the changing of seasons, but by the slow, eternal cycle of geological and chemical processes. If intelligent life ever arose on such a world, what would their concept of the universe be? Would they ever conceive of the idea of stars, of suns, of worlds warmed by distant fusion furnaces? Would they ever look to the sky, if their entire existence had been spent beneath an ice-covered ocean, their only awareness of the surface being the slow movements of ice and the occasional tremor of a distant impact? If we were to one day encounter such beings, would they see us as creatures of fire, of unbearable light, beings who come from a world they could never have imagined? But perhaps rogue planets are not merely the lost and the forgotten. Perhaps they are the carriers of something greater, the messengers of the universe, spreading the raw materials of life across the cosmos. A rogue planet passing through a young star system might deposit frozen organic compounds, scattering complex molecules onto the surfaces of forming planets. Could it be that the origins of life itself are not confined to any single world, but are instead a cosmic process, shaped by the journeys of these wandering planets? Humanity may one day set foot on a rogue planet, standing upon a surface that has never known sunlight, looking up into a sky empty of familiar constellations. It would be a world without a horizon, without the comforting cycle of day and night, an endless expanse of rock and ice stretching into the unknown. If we were to drill into its depths, what might we find? Could there be liquid water locked beneath the surface, hidden oceans teeming with alien organisms, waiting for the day when the ice is broken and the first light of an artificial sun shines upon them? Or would we find something even stranger, structures, artifacts, remnants of a civilization that once thrived in the depths of a planet now adrift? What if a world ejected from its solar system carried with it the final survivors of an intelligent species, forced to adapt to a life without a sun? Could we one day encounter beings who have lived for millennia in the cold, in the dark, sustained by technology and the fading warmth of their planet's core, clinging to existence as they drift between the stars? And if we were to find them, what would they think of us? Would they see us as explorers, as saviors, or as threats? Would they remember the warmth of a sun, or would that concept be nothing more than a myth, a legend passed down through generations who have never seen the light of a star? Perhaps, even now, rogue planets pass silently through the void near our solar system, unseen and undetected, their histories lost to time. Some may carry the frozen echoes of dead worlds, shattered civilizations, lost ecosystems locked away in ice. Others may be cradles of life, their hidden oceans still vibrant, waiting for the moment when they are discovered, when the first alien mind reaches out across the darkness and makes contact. And maybe, in some distant future, long after Earth has changed beyond recognition, humanity itself will leave its solar system behind, not on ships, but on planets. Perhaps, one day, we will ride a rogue planet into the unknown, adapting to its eternal night, becoming travelers of the void, just as these planets have done for billions of years before us. They are the forgotten worlds, the silent watchers, the unseen architects of cosmic history. They drift without light, without purpose, yet their presence shapes the very structure of the galaxy. They are the nomads of the universe, and their secrets are waiting to be uncovered. And so, rogue planets remain the greatest silent enigma of the cosmos, adrift, unseen, unclaimed by any sun, yet shaping the galaxy in ways we have only begun to understand. They are neither mere anomalies nor forgotten debris, they are relics of violent pasts, time capsules of planetary evolution, and perhaps even cradles of life hidden beneath layers of ice or thick, churning atmospheres. They are the restless exiles, wandering through the void with no beginning and no end, their journeys dictated by the cold, indifferent laws of gravity and chance. One day, we will no longer view them as distant mysteries. We will detect them with new technologies, track their silent paths, and finally lay eyes upon one of these lost worlds. We may send probes, robotic explorers that will land on their frozen plains or drill into their hidden oceans. With each discovery, we will uncover not just the secrets of the rogue planets themselves, but also the secrets of our own origins, of the forces that shaped Earth, of the materials that seeded life, of the delicate cosmic dance that determines the fate of planets. But science may not be the only reason we seek them. There is something deeply human in the idea of the wanderer, the eternal traveler, the lost yet undaunted. Rogue planets, in their silent solitude, reflect something fundamental about our own species, the need to move beyond the familiar, to venture into the unknown, to defy the boundaries of what we think is possible. In their endless drift, they whisper to us of futures we cannot yet imagine, of civilizations that may have risen and fallen in darkness, of life that might endure even in the loneliest corners of the universe. Perhaps, in some distant epoch, long after the Earth has changed beyond recognition, after our sun has expanded and faded, after humanity has scattered among the stars, we too will become wanderers. Perhaps we will make our home on a rogue planet, carving out a future in the eternal night, building cities that gleam beneath an artificial sky, sustained by the same forces that allow life to endure in the coldest depths of space. Perhaps, by then, rogue planets will no longer be mysteries, but the very vessels of our survival. Or perhaps, somewhere out there, a rogue planet is already watching us. Not in the way a living being watches, but as a silent witness, a drifting relic of something greater, something older than we can comprehend. Perhaps, long ago, it passed close to another world where eyes once gazed back at it, wondering, questioning, dreaming of what might be. Perhaps it has carried the last whispers of a lost civilization, preserved in its ice, waiting for someone to find it, to awaken the echoes of the past. And if one day we set foot upon a rogue planet, planting our flag in the frozen ground, marking our presence in a place that has known only emptiness, we will realize that these planets were never truly lost. They were always here, waiting in the void, carrying the forgotten stories of the universe, whispering their secrets to the stars. And at last, the universe will listen.
Gliese 581g, a planet shrouded in intrigue and scientific fascination, orbits its dim, red dwarf star, Gliese 581, situated approximately 20 light-years away in the Libra constellation. Discovered in 2010, this exoplanet quickly captured the imagination of scientists and the public alike due to its potential for habitability. Its location within the so-called habitable zone of its parent star sparked widespread discussion about the possibility of extraterrestrial life and the conditions necessary to sustain it. The habitable zone, often referred to as the Goldilocks zone, is a region around a star where conditions might allow liquid water to exist, a critical ingredient for life as we know it. Unlike Earth, which orbits a yellow G-type star, Gliese 581g circles an M-class red dwarf. These stars are cooler, smaller, and longer-lived than our Sun, making them intriguing targets for the search for habitable worlds. Red dwarfs comprise the majority of stars in the Milky Way galaxy, suggesting that habitable zone planets like Gliese 581g could be more common than initially thought. What makes Gliese 581g particularly captivating is its size and mass, which suggests that it could be a rocky planet like Earth. Its minimum mass is estimated to be about 3 to 4 times that of Earth, placing it within the range of super-Earths. Super-Earths are planets larger than Earth but smaller than gas giants, a category that has no direct analog in our solar system. The radius of Gliese 581g, while not directly measured, is inferred to be about 1.5 times that of Earth, based on its mass and density assumptions. This size raises questions about the planet's geological activity, magnetic field, and ability to retain an atmosphere, all crucial factors for habitability. The parent star, Gliese 581, is relatively dim, emitting only about 1.3% of the Sun's luminosity. As a result, the habitable zone lies much closer to the star. Gliese 581g completes one orbit in just 36.6 Earth days, indicating a much shorter year compared to our planet. Being so close to its star, Gliese 581g is likely tidally locked, meaning one side perpetually faces the star while the other remains in darkness. This configuration creates stark contrasts in temperature between the day and night sides, with a narrow twilight zone, a terminator line, where conditions might be more temperate. The potential for life hinges on the planet's atmosphere, if one exists. An atmosphere could moderate temperature extremes, facilitating heat redistribution between the star-facing and dark sides. Without an atmosphere, the planet's surface would likely be inhospitable, with one hemisphere baking under constant starlight while the other freezes in perpetual night. The discovery of Gliese 581g emerged from meticulous analysis of radial velocity data. This method detects wobbles in a star caused by the gravitational pull of orbiting planets. The wobble in Gliese 581's motion suggested the presence of multiple planets, including Gliese 581g. However, The initial excitement surrounding its discovery was tempered by subsequent debates. Some studies questioned the planet's existence, attributing the detected signals to stellar activity rather than a planetary companion. Yet, subsequent reanalyses of the data have reignited interest, with some researchers asserting that the planet's existence cannot be ruled out. The tantalizing possibility of Gliese 581g has inspired numerous theoretical studies. Simulations suggest that if the planet has an atmosphere with greenhouse gases like carbon dioxide, it could maintain surface temperatures conducive to liquid water, particularly in the terminator zone. The planet's gravity, estimated to be about 1.1 to 1, 7 times that of Earth's, would allow it to hold onto an atmosphere, further enhancing its potential for habitability. Observing Gliese 581g directly remains a formidable challenge due to its distance and the limitations of current technology. However, future telescopes like the James Webb Space Telescope and next-generation ground-based observatories could provide crucial insights. Spectroscopic analysis might reveal the presence of atmospheric components such as water vapor, oxygen, or methane, potential biosignatures. The search for habitable worlds like Gliese 581g underscores humanity's enduring quest to understand our place in the cosmos. As we develop more advanced technologies and refine our techniques, the possibility of confirming the existence of life beyond Earth inches closer to reality. Gliese 581g remains a symbol of scientific curiosity, a beacon guiding us toward the stars, and a reminder of the vast, unexplored frontier that awaits humanity. The allure of Gliese 581g extends beyond its scientific significance. It challenges our understanding of habitability, planetary formation, and the dynamics of star systems. In the years since its discovery, this enigmatic world has sparked intense debates within the scientific community. While some researchers remain skeptical of its existence, others argue that the data strongly supports the presence of a planet within Gliese 581's habitable zone. This divide highlights the complexity of exoplanet detection and the necessity for continuous improvement in observational techniques. If Gliese 581g is indeed a real, rocky planet, its surface environment could be shaped by numerous factors, including its geological activity, atmospheric composition, and interaction with stellar radiation. The tidally locked nature of the planet presents unique challenges for habitability, yet it also opens fascinating possibilities. The constant daylight on one side and perpetual night on the other create extreme environmental contrasts, potentially driving dynamic atmospheric and oceanic currents. If liquid water exists, the terminator zone, where the two hemispheres meet, is particularly intriguing as a potential haven for life. This narrow region might offer moderate temperatures, where the interplay of light and dark could sustain a diverse range of climates and ecosystems. Astrobiologists speculate that any life on Gliese 581g, if present, would have adapted to these extreme conditions. On the star-facing side, organisms might evolve to withstand high levels of radiation and heat, perhaps developing reflective surfaces or protective biofilms. In the dark hemisphere, life could depend on geothermal heat or chemical energy sources, much like extremophiles on Earth that thrive in hydrothermal vents. The terminator zone, with its relatively stable and temperate conditions, might host the richest diversity of life, with ecosystems that bridge the light and dark worlds. The potential for life on Gliese 581g also raises profound philosophical and existential questions. What would the discovery of extraterrestrial life mean for humanity? How would it reshape our understanding of biology, evolution, and the universe itself? These questions drive not only scientific inquiry but also inspire art, literature, and culture. reflecting humanity's deep yearning to connect with the cosmos. From a technological perspective, the search for Gliese 581g and similar planets has fueled advancements in observational astronomy. Techniques such as transit photometry, direct imaging, and radial velocity measurements have become increasingly sophisticated, enabling the detection of smaller and more distant exoplanets. Instruments like the Transiting Exoplanet Survey Satellite, TESS, and the European Space Agency's Cheops mission are paving the way for more detailed studies of planetary systems. Meanwhile, ground-based observatories equipped with adaptive optics are pushing the boundaries of resolution, allowing astronomers to probe the atmospheres of distant worlds. Future missions, such as the planned LUVOIR and HABEX telescopes, aim to directly image Earth-like exoplanets and analyze their atmospheres for biosignatures. These cutting-edge instruments could potentially confirm the existence of Gliese 581g and provide crucial data about its surface and atmospheric conditions. Such observations would represent a monumental leap forward in our quest to identify habitable worlds and answer the age-old question: are we alone in the universe? The study of Gliese 581g also has implications for planetary science and the theory of planetary system formation. The Gliese 581 system, with its multiple planets spanning a range of orbits, offers a valuable case study for understanding how planets evolve in the vicinity of red dwarf stars. Red dwarfs are known for their intense stellar activity, particularly during their early stages, when frequent flares can bombard nearby planets with high-energy radiation. These conditions could strip atmospheres or significantly alter planetary surfaces. Yet planets like Gliese 581g might survive such tumultuous phases, raising questions about the resilience of potentially habitable worlds. Moreover, the discovery of Gliese 581g underscores the importance of interdisciplinary research in exoplanetary science. Astrophysics, geology, atmospheric chemistry, and biology converge to paint a more complete picture of what life on such a planet might look like and how we might detect it. Collaborative efforts between scientists across these fields are essential to unravel the mysteries of Gliese 581g and its counterparts. Public engagement with the discovery of Gliese 581g has been equally significant. The idea of a potentially habitable planet so close to Earth has captured the imagination of millions, fostering a renewed interest in space exploration and astronomy. It has also highlighted the need for continued investment in space science and education, ensuring that future generations are equipped to tackle the challenges and opportunities of exploring the universe. As humanity stands on the brink of a new era in space exploration, Gliese 581g serves as a vast, uncharted territories that lie beyond our solar system. Whether or not this planet ultimately proves to be habitable or even real, it has already played a pivotal role in advancing our understanding of the cosmos and inspiring a sense of wonder about the possibilities that await us among the stars. The journey to uncover the truth about Gliese 581g is a testament to human curiosity, resilience, and our enduring desire to explore the unknown. It is a journey that will continue to shape our understanding of the universe and our place within it for generations to come. Gliese 581g represents one of the most captivating enigmas in the field of exoplanet research, offering an opportunity to delve into questions that bridge astronomy, biology, and planetary science. The planet's potential habitability has made it a focal point for studies that explore the conditions necessary for life beyond Earth, driving innovation and collaboration across scientific disciplines. Orbiting its red dwarf parent star at a distance that places it within the habitable zone, Gliese 581g has the unique distinction of being one of the earliest exoplanets identified as a candidate for hosting liquid water on its surface. The mere suggestion of such a possibility set off a flurry of scientific papers, debates, and theoretical models aimed at understanding the characteristics of this world and its potential to harbor life. The characteristics of red dwarf stars like Gliese 581 are critical to this discussion. As the most common type of star in our galaxy, red dwarfs offer a promising avenue for finding habitable planets due to their long lifespans and prevalence. However, these stars also pose challenges, particularly in their propensity for stellar flares and high levels of radiation during their early evolutionary stages. For Gliese 581g, this raises questions about the stability and survivability of its atmosphere over geological timescales. If the planet's atmosphere has endured these conditions, it could act as a protective layer, shielding the surface from harmful radiation and maintaining temperatures conducive to liquid water. Researchers have hypothesized that the composition of such an atmosphere would play a pivotal role in its ability to sustain life. A thick atmosphere rich in greenhouse gases like carbon dioxide could help moderate temperatures across the planet's surface, especially given its likely tidally locked rotation. In a tidally locked state, one side of Gliese 581g would face perpetual daylight while the other remains in constant darkness. This configuration creates extreme temperature gradients, but an atmosphere with robust circulation patterns could distribute heat more evenly, making the twilight zone between day and night a potential hotspot for habitability. The geological features of Gliese 581g, though entirely speculative at this stage, add another layer of intrigue to the planet's story. A rocky composition with active tectonics could support the recycling of carbon and other life-sustaining elements, a process that is vital for maintaining a stable climate over long periods. Volcanic activity could also release gases into the atmosphere, contributing to its density and composition while providing energy sources for potential microbial life forms. The question of water, arguably the most crucial ingredient for life, remains central to discussions about Gliese 581g. If liquid water exists on the planet, it could take various forms, from vast oceans covering the terminator zone to subsurface reservoirs protected from the harsh conditions of the surface. The presence of water would not only enhance the planet's habitability but also provide a medium for chemical interactions that could lead to the emergence of life. The discovery of Gliese 581g and the subsequent debates about its existence highlight the challenges inherent in exoplanet detection. The radial velocity method used to identify the planet relies on detecting the minute wobbles in a star's motion caused by the gravitational pull of orbiting planets. While this technique has proven highly effective, it is not without its limitations, particularly when it comes to disentangling planetary signals from stellar activity. In the case of Gliese 581g, this has led to conflicting interpretations of the data, with some studies affirming the planet's presence and others attributing the observed signals to noise or activity within the star itself. Despite these uncertainties, the prospect of Gliese 581g has galvanized efforts to improve detection methods and refine our understanding of planetary systems. Advances in spectroscopy, adaptive optics, and space-based observatories have opened new frontiers in the study of exoplanets, enabling scientists to probe the atmospheres, compositions, and climates of distant worlds with increasing precision. For Gliese 581g, future missions capable of directly imaging exoplanets or analyzing their atmospheric spectra could provide definitive answers about its characteristics and potential for habitability. Beyond its scientific implications, Gliese 581g holds a special place in the broader narrative of humanity's search for life beyond Earth. The idea of a potentially habitable planet within our cosmic neighborhood has captured the imagination of people around the world, serving as a source of inspiration and wonder. It underscores the importance of exploring the universe, not only to satisfy our curiosity, but also to gain perspective on our own planet and the fragile ecosystems it supports. The search for Gliese 581g is part of a larger journey to understand the conditions that give rise to life and the factors that enable it to thrive. It challenges us to consider the diversity of planetary environments that might exist in the universe and the ways in which life could adapt to conditions vastly different from those on Earth. Whether Gliese 581g ultimately proves to be habitable or even real, its story exemplifies the spirit of discovery that drives scientific exploration and the unyielding human desire to seek answers to the fundamental questions of existence. In the coming decades, as new technologies and missions take us closer to uncovering the secrets of distant star systems, Gliese 581g will remain a symbol of the possibilities that await us in the uncharted realms of the cosmos. It is a reminder that the universe is vast, mysterious, and full of potential, beckoning us to look beyond our own world and envision the countless others that lie waiting to be discovered. The mystery of Gliese 581g deepens with every question we ask, pulling us into an intellectual adventure that stretches the boundaries of science and imagination. What if this distant world, orbiting a star so unlike our sun, harbors secrets that could redefine our understanding of life itself? Imagine standing on its twilight line, the narrow strip where day perpetually meets night, under a crimson sky painted by the faint glow of its red dwarf star. This region, balanced between scorching heat and frigid cold, could be a crucible of possibilities, a place where chemistry dances on the edge of biology, where alien ecosystems might thrive in conditions we can barely fathom. But the intrigue doesn't end there. The planet's tidally locked nature could create bizarre and extreme weather patterns. On the sunlit side, relentless winds might scour barren landscapes, their fury shaped by the intense gravitational pull of Gliese 581. On the dark side, perpetual night might shroud frozen plains in eternal silence, broken only by the faint whispers of atmospheric currents. Yet in the Terminator zone, where the extremes meet, we might find an otherworldly equilibrium, a place where liquid water flows in alien rivers, carving paths through landscapes no human eye has yet seen. Consider the possibilities for life under such conditions. Life on Gliese 581g, if it exists, would likely be unrecognizable to us. On the sunlit side, photosynthetic organisms might harness the weak, reddish light of their star, evolving pigments unlike anything on Earth. Their slow, deliberate metabolic processes could mirror the measured rhythm of a star that lives for trillions of years. Meanwhile, in the eternal night, bioluminescent creatures could navigate the darkness, their faint glows illuminating the icy void. Life in the Terminator zone might bridge these extremes, adapting to the cycles of warmth and cold, light and dark, in ways we can only begin to theorize. Even the planet's potential atmosphere fuels the imagination. Could it be a dense, greenhouse-rich envelope that traps heat and nurtures liquid water on the surface? Or perhaps it's a thin, fragile veil, constantly replenished by geological activity. Volcanoes, spewing gases into the sky, might create fleeting auroras visible from space, spectacles that tell a silent story of a world alive with unseen processes. Gliese 581g also represents a profound challenge for our technology and ingenuity. How do we study a planet so distant, so veiled in mystery? Current telescopes and instruments can only infer its existence through indirect measurements, tantalizing us with clues but offering no direct glimpse. Yet, the dream of seeing this world in detail, its mountains, valleys, and oceans, if they exist, is not out of reach. The next generation of space telescopes, equipped with advanced imaging capabilities, could one day reveal its secrets. Imagine the moment when humanity captures the first image of this alien world, a pale, distant orb shimmering in the vastness of space. And what if, buried in its spectral data, we find the signatures of life? Methane, oxygen, or even more exotic chemicals could signal biological activity, raising questions that transcend science. How did life begin there? What forms has it taken? And what does its existence mean for us, for our place in the universe, and for the story of life itself? As we peer deeper into the cosmos, Gliese 581G serves as a beacon, a reminder of the limitless potential of discovery. It challenges us to dream bigger, to push the boundaries of what we know, and to explore the vast, uncharted frontier of interstellar space. For every answer we uncover, 1,000 new questions arise, each more tantalizing than the last. The universe is calling, and Gliese 581G is one of the voices whispering back, daring us to uncover its secrets and confront the extraordinary possibilities that lie beyond the veil of the familiar. The story of Gliese 581G continues to unfold as both a scientific mystery and a symbol of humanity's enduring fascination with the unknown. This planet, locked in a gravitational dance with its faint red dwarf star, tantalizes us with the possibility that it might be more than a barren rock adrift in the cosmos. It might be a world alive, dynamic, and teeming with answers to questions we've only just begun to ask. The implications of its potential habitability resonate far beyond the confines of academic research. They reach into the realms of philosophy, art, and our deepest existential curiosities. Picture the landscape of Gliese 581G as you might imagine it. On the day side, bathed in the dim, red light of its star, rocky terrain might stretch endlessly, pockmarked by craters and perhaps softened by the erosion of ancient winds. Dust particles, caught in the weak yet persistent pull of gravity, could linger in the thin air, diffusing the starlight into surreal, otherworldly hues. Temperatures on this hemisphere might soar, baking the surface into a parched expanse that challenges even the hardiest of hypothetical life forms. And yet, the potential for adaptation here remains a source of endless speculation. Microbes capable of tolerating heat, shielded beneath layers of rock or protected by biofilms, could thrive where we see desolation. The night side, by contrast, plunges into eternal darkness, a frigid and silent abyss where temperatures might plummet to extremes unimaginable on Earth. Here, ice could dominate, covering the ground in thick, immovable sheets that glisten faintly under the weak glow of distant stars. Beneath this frozen crust, however, life might persist in liquid water reservoirs, heated by the planet's geothermal energy. Organisms might rely on chemosynthesis, drawing energy from the planet's inner heat and mineral-rich waters. These ecosystems, if they exist, could mirror those found around Earth's hydrothermal vents, cradles of life that flourish in the absence of sunlight. But it is the terminator zone, the narrow band where day meets night, that captivates the imagination most profoundly. Here, conditions might be just right for liquid water to exist on the surface, a key ingredient for life as we know it. The interplay of light and shadow could create a dynamic environment, with winds transporting heat from the day side to the night side, moderating temperatures and fostering climatic stability. The twilight region could host alien lakes or even shallow seas, reflecting the red glow of the star in shimmering waves. If vegetation or microbial mats exist, they might cover the ground in vibrant, otherworldly colors, evolving pigments to absorb the limited light efficiently. From a scientific perspective, the potential habitability of Gliese 581g raises critical questions about the resilience and adaptability of life. On Earth, extremophiles thrive in conditions once thought inhospitable, within acidic hot springs, beneath kilometers of ice, and even in radioactive environments. These organisms challenge our assumptions about where life can exist and push us to expand our search criteria for extraterrestrial life. Could Gliese 581g, with its extremes of light and dark, heat and cold, be a crucible for similar extremophiles? So, what might their biochemistry look like? Would it rely on carbon and water as Earth's life does? Or could it be based on entirely different elements and compounds, rewriting the rules of biology? To answer these questions, scientists are turning to cutting-edge technology and innovative methods. The hunt for biosignatures on Gliese 581g hinges on spectroscopy, a technique that analyzes the light passing through a planet's atmosphere to detect chemical fingerprints. By studying the light from its host star as it interacts with the planet's atmosphere, we might detect gases like oxygen, methane, or ozone molecules that, on Earth, are closely associated with life. The detection of these compounds in specific ratios could signal biological activity, providing indirect yet compelling evidence of life on this distant world. However, observing Gliese 581g directly presents formidable challenges. At a distance of 20 light-years, it is too faint to be resolved by most current telescopes. But the next generation of observatories, such as the Extremely Large Telescope, ELT, and the James Webb Space Telescope, JWST, promises to revolutionize our ability to study exoplanets. Equipped with advanced imaging systems and spectrographs, these instruments could reveal not only the composition of Gliese 581g's atmosphere, but also its surface temperature, albedo, and even signs of seasonal changes, indicators of an active, dynamic environment. Beyond the scientific intrigue, the discovery of a potentially habitable world so close to Earth has profound implications for humanity's future. It forces us to confront the possibility that we are not alone in the universe, a realization that could fundamentally alter our worldview. It challenges us to think about life not just as a phenomenon unique to our planet, but as a cosmic inevitability, arising wherever conditions allow. And it inspires us to dream of the day when we might send probes, or even humans, to explore such worlds firsthand. The journey to Gliese 581g is one of imagination as much as science. It beckons us to look up at the night sky and wonder, what would it feel like to stand on this alien world, to breathe its air, hear its sounds, and experience the strange beauty of its landscapes? What stories would its rocks tell, and what secrets might its waters hold? These questions, unanswered and open-ended, are a testament to the boundless curiosity that drives us to explore, to push beyond the limits of what we know, and to seek out the unknown. In this pursuit, Gliese 581g is more than just a planet. It is a symbol of possibility, a reminder that the universe is vast and full of wonders waiting to be discovered. It represents the next chapter in our journey of exploration, a journey that has taken us from the shores of Earth to the farthest reaches of our solar system and now to the stars beyond. The story of Gliese 581g is, in many ways, our own story, one of resilience, curiosity, and an unyielding drive to understand the cosmos and our place within it. And as we continue to search for answers, this enigmatic world remains a beacon of hope and inspiration, calling us ever onward into the great unknown. The enigma of Gliese 581g deepens with every theoretical exploration, each new layer of possibility stirring the imagination and pushing the boundaries of human understanding. What if this distant world is not only habitable but inhabited? What forms of life might have evolved under the unique conditions imposed by its red dwarf star? Could its ecosystems, shaped by an interplay of perpetual day, eternal night, and the temperate twilight in between, reveal evolutionary trajectories that defy anything seen on Earth? The sheer adaptability of life as we know it suggests that even the most extreme environments on Gliese 581G might harbor organisms. On Earth, tardigrades survive in the vacuum of space, extremophiles thrive in boiling acidic springs, and microbes flourish beneath miles of Antarctic ice. Life on Gliese 581G, if it exists, could have adapted to its own extremes with equal ingenuity. On the sunlit side, organisms might have evolved biochemical shields against the intense radiation emitted by its star, perhaps using pigments that not only protect but also harness the weak red light for energy. These creatures could be analogous to Earth's cyanobacteria, the pioneers of oxygenic photosynthesis that once transformed our planet's atmosphere. In the icy darkness of the night side, life might depend on geothermal energy rather than starlight. Beneath layers of ice, vast subsurface oceans, kept liquid by the heat from the planet's interior, could support ecosystems much like those found near Earth's hydrothermal vents. Here, chemosynthetic bacteria might form the base of a food chain that includes complex multicellular organisms, all thriving in complete darkness. Imagine the sight of bioluminescent creatures illuminating these underworld oceans, their ghostly light creating a living galaxy beneath the ice. The Terminator Zone, that fascinating strip where light and dark meet, presents a unique frontier for habitability. Here, the balance of temperature and light could create an environment not only suitable for life but one rich in biodiversity. This region might host alien forests, sprawling across a landscape where the dim red light nurtures strange, slow-growing plants or fungal analogs. These organisms could form the basis of a complex ecosystem, one where herbivores, scavengers, and predators have evolved in ways dictated by the planet's peculiar rhythms. And then there is the question of intelligence. Could life on Gliese 581G have evolved beyond the microbial stage? Could sentient beings, shaped by the challenges of their environment, have developed civilizations on this distant world? If so, what would their cultures look like and how might they perceive the universe? Would they gaze at the stars, as we do, and wonder if they are alone? These speculative musings drive the profound sense of wonder that Gliese 581G inspires. But the scientific challenges of studying such a planet are as vast as its potential. The faint light from Gliese 581G carries whispers of its composition, its atmospheric chemistry, and perhaps even its weather patterns. By analyzing this light with advanced spectrographs, we might one day detect molecules like water vapor, carbon dioxide, or methane, compounds that could hint at the presence of life. Even more tantalizing would be the discovery of biosignatures such as oxygen or ozone, which, in certain contexts, could be indicative of biological processes. Future telescopes, such as LUVOIR or HABEX, promise to revolutionize our ability to study planets like Gliese 581G. Equipped with instruments capable of imaging Earth-sized planets and analyzing their atmospheres, these observatories could transform our theoretical models into empirical knowledge. The dream of seeing Gliese 581G's surface, its landscapes, its oceans, and perhaps even its clouds, is not beyond reach. Such an achievement would mark a turning point in human history, providing not just answers but new questions about our place in the cosmos. As we look toward the future, the journey to understand Gliese 581G reflects humanity's broader quest for meaning and connection. This distant world, so far beyond our grasp yet so tantalizingly close in astronomical terms, represents a bridge between the known and the unknown. It reminds us that the universe is vast, filled with mysteries that challenge our intellect and inspire our creativity. The pursuit of Gliese 581G is a testament to the unyielding human spirit, our relentless curiosity, and our capacity to dream beyond the confines of our present reality. Every step we take in unraveling the secrets of Gliese 581G brings us closer to answering some of the most profound questions we can ask. Are we alone in the universe? Is life a rare accident, confined to the pale blue dot we call home, or a common thread woven throughout the cosmic tapestry? Gliese 581G stands as a beacon in this search, a symbol of what lies beyond, waiting for us to discover it. Its story is not just a scientific narrative. It is a human one, a story of wonder, exploration, and the timeless desire to reach for the stars. The story of Gliese 581G unfolds like an endless narrative, one that pulls us deeper into the mystery of our universe with every new thought, every unanswered question. As we dream of this world, distant yet tantalizingly close in cosmic terms, we are reminded of the unyielding drive to explore the unknown, to uncover truths about ourselves through the distant echoes of alien landscapes. What if Gliese 581G is more than just habitable? What if it is alive, its ecosystems thriving in conditions completely foreign to human experience? Its red dwarf star, Gliese 581, may shine dimmer and cooler than our sun, but its stability over billions of years offers a fertile ground for life to evolve. Unlike massive stars that burn out quickly, red dwarfs endure for trillions of years, their longevity providing a long and steady backdrop for biological complexity to arise. Could this cosmic stability have fostered life forms with an ancient evolutionary lineage, far surpassing the mere 4.5 billion years of life's history on Earth? Imagine beings shaped by the peculiarities of their environment. If intelligent life exists on Gliese 581G, how would it have adapted to a tidally locked world? On the perpetual day side, would civilizations have evolved to harness the constant low-energy red light of their star, building cities that stretch into the blazing horizon? On the dark side, might they have carved their homes into the icy crust, using geothermal heat as a lifeline in the unending cold? In the Terminator zone, where the two extremes meet, could there be societies that thrive in balance, their lives shaped by the interplay of light and darkness, warmth and cold? The possibility of intelligent life raises profound questions about communication. If beings on Gliese 581G possessed technology, would they have tried to signal their presence to the cosmos? Could their messages, traveling at the speed of light, already be on their way to us, waiting to be intercepted by our instruments? Or, conversely, could we send messages to them, carefully encoded radio waves or laser pulses designed to announce our presence and invite dialogue? The prospect of such contact ignites the imagination, bridging the vast interstellar gulf with a spark of shared curiosity. But the road to uncovering these possibilities is fraught with challenges. Observing Gliese 581G directly requires pushing the boundaries of modern astronomy. At a distance of 20 light-years, the planet appears as little more than a faint point of light against the vastness of space. Yet that faint light holds the keys to its secrets. By splitting the light into its spectral components, astronomers can infer the planet's atmospheric composition, surface conditions, and even signs of seasonal change. Each discovery would add a new layer to the story, transforming speculation into knowledge. Even with our most advanced technologies, reaching Gliese 581G remains a distant dream. At our current pace of space travel, a journey to this exoplanet would take tens of thousands of years. Yet visions of interstellar exploration persist, fueled by concepts like solar sails, fusion propulsion, and wormholes. Each new technological breakthrough brings us a step closer to turning science fiction into science fact, to transforming Gliese 581G from a point of light in the sky into a destination for exploration. As we await these advances, the scientific community continues to debate the very existence of Gliese 581G. The signals that hint at its presence are subtle, buried in the noise of stellar activity and the complexities of its star's motion. Some argue that the planet is a ghost, an artifact of flawed data analysis. Others remain convinced that it is real, pointing to patterns that align too precisely with the characteristics of a planetary body to be mere coincidence. This ongoing debate underscores the challenges of exoplanet detection, reminding us that science is a process, one that thrives on questioning, refinement, and discovery. Yet, even if Gliese 581G were to prove elusive, the questions it raises endure. What would it mean for life to exist so far from Earth? How would such a discovery reshape our understanding of biology, of evolution, and of ourselves? Would we see ourselves as unique, a rare anomaly in an otherwise barren universe? Or would we come to understand that life is not an exception but a rule, a natural consequence of the cosmos' inherent creativity? The search for answers propels us forward, inspiring new missions, new technologies, and new ways of thinking. In pursuing Gliese 581G, we are not merely exploring a distant world. We are exploring the very essence of what it means to be human. Our curiosity, our ingenuity, and our desire to understand the universe are as much a part of this story as the planet itself. As the narrative of Gliese 581G continues to evolve, it invites us to dream boldly and think deeply. It challenges us to look beyond the immediate and familiar, to imagine what lies beyond the edge of our knowledge. And it reminds us that the universe is vast, filled with wonders that await our discovery. Gliese 581G, whether real or hypothetical, stands as a symbol of this limitless potential, a reminder that the journey to understanding is as infinite as the cosmos itself. In the pursuit of this enigmatic world, we find not only the promise of answers, but also the enduring thrill of the unknown. The intrigue surrounding Gliese 581G only grows as we consider the implications of its potential for life, its role in the broader search for habitable worlds, and what it tells us about the universe's boundless possibilities. It exists in a delicate balance of mystery and promise, a world that could be a thriving hub of alien ecosystems or a silent, barren outpost, waiting for the touch of human exploration to give it meaning. One of the most fascinating aspects of Gliese 581G is how it forces us to rethink habitability itself. For decades, scientists believed that life could only flourish in conditions similar to those on Earth: temperate climates, abundant liquid water, and a stable atmosphere. Yet, as we discover more exoplanets and study extremophiles here on Earth, our understanding of life's resilience has expanded dramatically. Could Gliese 581G, with its stark contrasts of light and dark, host forms of life that have evolved to exploit its unique environment? Imagine standing on the planet's terminator line, where the eternal sunrise or sunset would paint the sky in otherworldly hues. The landscape could be a fusion of molten rock and icy plains, with rivers of liquid water meandering through the temperate middle. Winds might sweep across this boundary, carrying warmth from the sunlit side into the frozen darkness, creating a dynamic weather system. If Gliese 581G has an atmosphere, its composition could be entirely alien to us. a mix of exotic gases that sustain life forms unrecognizable by earthly standards. Perhaps the skies are filled with drifting organisms, floating like jellyfish on currents of heated air, their translucent bodies glowing faintly in the crimson light. On the perpetual night side, the darkness might be pierced only by flashes of bioluminescence or the faint flicker of volcanic eruptions. Here, life could be deeply subterranean, thriving in caverns warmed by geothermal energy. The idea of ecosystems thriving in complete isolation from their sun, powered solely by the heat of the planet's core, is not entirely foreign to us. On Earth, similar communities exist around hydrothermal vents at the bottom of our oceans, where sunlight never penetrates. The day side, exposed to constant starlight, could be a harsh and unforgiving desert. Yet even here, life might find a way. Organisms could evolve to withstand the radiation of the red dwarf, using biochemical shields or developing pigments that convert the intense energy into a usable form. Life on this side might resemble hardy desert flora or subterranean microbes, hiding beneath the surface to escape the relentless heat. And then there is the question of time. If Gliese 581g is real, it has existed for billions of years, orbiting a star that will outlive our own by trillions more. What if life there has had eons longer than life on Earth to evolve and diversify? Could it have reached levels of complexity and intelligence far beyond our comprehension? The potential age of this system presents a tantalizing possibility. That Gliese 581g could host ancient civilizations or the ruins of ones that rose and fell long before humanity began its ascent. The search for intelligent life brings with it profound questions about communication and understanding. How would beings from a tidally locked world perceive time, space, and existence? Would they even recognize us as intelligent? Or would our perspectives and forms be as alien to them as theirs would be to us? Efforts like the search for extraterrestrial intelligence, SETI, aim to answer these questions, scanning the skies for signals that might reveal the presence of advanced civilizations. Gliese 581g, with its potential habitability, is a prime candidate for such investigations. A single signal, even a faint, undecipherable one, would change everything we know about our place in the universe. Yet Gliese 581g is not just a beacon of scientific interest. It is a symbol of hope, curiosity, and the boundless human drive to explore. Its existence, debated as it may be, has already reshaped the way we think about exoplanets and the search for life. It has inspired advancements in technology, from more sensitive spectrographs to ambitious missions designed to image distant worlds directly. The dream of not just studying Gliese 581g from afar but one day sending probes, or even humans, to its surface feels closer with every technological leap. Such an endeavor would mark a turning point in human history. Imagine the moment when a probe enters orbit around Gliese 581g, capturing detailed images